using ratios to solve problems. We need to be able to simplify ratios and use equivalent ratios, so this is just a reminder. When we're simplifying ratios, we need to make sure they're the same unit or no units, so we're just counting things, and then we divide by the HCF. So this ratio here, 10 to 15, there's no units given, so we don't need to worry about that. We look for the highest common factor. The HCF here is 5. 5 is the biggest number that goes into both of them, so we're dividing both sides by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So our simplified ratio, it's just like simplifying a fraction. Find the highest common factor and divide both sides by it. This is fine even if there's 3 numbers in the ratio. Find the highest common factor of all 3. 2 is the biggest number that goes into all of them. 2 divided by 2 is 1. 6 divided by 2 is 3. 4 divided by 2 is 2. So we divide all parts of the ratio by the highest common factor. Sometimes they give us a ratio with units, and here they're different units. If they're not in the same unit, you've got to make them the same unit. So I've got millimetres and centimetres. I can get centimetres to be millimetres by multiplying by 10. So that would be 40 millimetres to 3 millimetres. Once you've got the same units, then in a ratio you can remove the units. Sorry, I meant to have a space there. Remove the units, so it's just 40 to 3. Check if there's a highest common factor. There's not, so that's as far as it could have gone. If there was a highest common factor, we could simplify further. So if a ratio has units, we have to get them to be the same unit and then divide it. If this was like 4 kilograms to 3 millimetres, that's not a ratio, because they're different things. Kilograms is weight, millimetres is length. But both length, we can get them to be the same unit. A reminder about equivalent ratios. This is just like equivalent fractions. 2 to 1 is 10 to what? If we were doing equivalent fractions, we might get a question where it was 3 over 4 equals what over 12? It's exactly the same sort of questions, because ratios and fractions are really closely related. And we'd ask ourselves, what did I do to the 4 to get 12? That was times 3. Now if you can't tell, divide back. 12 divided by 4 gives me 3. That means 4 times 3 is 12. And I do the same thing to this. 3 times 3 is 9, and I've got equivalent fractions. Same thing here. The first thing, what did I do to 2 to get 10? It's got to be times or divide. 2 times 5 would give me 10, so I've got to do 1 times 5 to get 5. And they'll always keep the same relationship. This one's half of this one's half of this. So they'll always get that same relationship. That's how you get equivalent ratios. So we're using ratios to solve problems. A woman mixes sand and cement in the ratio 5 to 2. That means sand comes first in the question. So this is sand, this is cement. And however much cement we use, 2 bits of cement, we use 5 bits of whatever that was in sand. If she uses 6 buckets of cement, how much sand does she use? So our first step is to write and label the ratio. Sand and cement, so we have to keep it in order. Sand, then cement. It's 5 to 2, remember, it's an S. Remember, order is important. So that's the ratio as it's been given to us. And then we put in what we know. So I know there's 6 buckets of cement. Now this is an equivalent ratio. If you prefer, you can write it as an equivalent ratio. 5 to 2 equals what to 6? Or we can leave it set out like this. How did we get, so I've got the second thing, I've got the cement value. What did I do to 2 to get 6? I have to multiply or divide. 2 times 3 is 6. So I've got to do the same thing to the sand. Times 3, 5 times, she needs 15 buckets of sand if she uses 6 buckets of cement. Or I could have done that working here. How did I get from 2 to 6 with the cement? Well, I had 3 lots of 2. So I've got to do the same thing here, 15. And because it's a word question, a word answer, she needs 15 buckets of sand. So we write and label our ratio, we put in our known value, and then we use equivalent ratios to solve that. The ratio of teachers to students on an excursion is 1 to 17. If there are 51 students, how many teachers are there? Write and label the ratio in order, teachers to students. Underneath the known ratio, 1 to 17. Underneath the correct spot, which is students, put in our known value, 51. And now it's an equivalent ratio. What did I do to 17 to get 51? Now that's a hard question. So, check going back the other way with a division. 51 divided by 17 is 3. That means 17 times 3 is 51. Let's check that. 17 times 3 is 51. That was times 3, so this needs to be times 3, 3 teachers. So you're pretty much saying, well, I've got 3 lots of the 17. I need 1 teacher for every 17 students, so I need 3 lots of teachers to balance that out. And because it's a word question, word answer, how many teachers are there? There are 3 teachers